Now it's your turn to solve an equation using factoring and the zero product principle. Stop this video, take a moment to write out your answers to these problems in your lecture outline packet, and then turn the video back on to check your answer. The equation that we're asked to solve here is 4x squared minus 81 equals 0. So to start, we'll write that equation down. And it's already set equal to 0, so our task is to factor that left-hand side. So to factor 4x squared minus 81, we want to note that this is a binomial. So with binomials, we have very limited options as to how we can factor that. Looking at 4x squared and negative 81, they do not have a greatest common factor. So we're going to look for other techniques. 4x squared and 81 are both perfect squares. So we're going to use the difference of two squares, which says that a squared minus b squared is equal to the product of a minus b and a plus b. A and b are determined by what we've squared. So with 4x squared, we have squared 2x. And with 81, we have squared 9. So this will factor into 2x minus 9 times 2x plus 9. And at this point, I've broken it down into the product of two linear factors, and I can apply the zero product principle. So from here, I'll get 2x minus 9 equal to 0, or 2x plus 9 equal to 0. Now we'll go and solve each of these linear equations. 2x minus 9 equals 0, I can solve by adding 9 to each side, which will give me 2x equals 9. And then lastly, I'll divide each side by 2, which will mean that x is equal to 9 halves. Going over to 2x plus 9 equals 0, subtracting 9 from each side will give 2x equal to negative 9, and then dividing each side by 2 will give x equal to negative 9 over 2. I now have two proposed solutions, so I'll check them, and I'll do that by looking at that original equation. So I'll check x equals 9 halves, and I'll do that by replacing 9 halves for x in that original equation. So 4 times 9 halves, quantity squared, minus 81, I'm going to check, does that equal 0? 4 times 9 halves will be 4 times 81 over 4, and then I'm subtracting 81 and checking if that equals 0. So 4 times 81 over 4 will give me 81, so I'm checking, does 81 minus 81 equal 0? And yes, it does. I'll now check x equals negative 9 halves, and I'll do that by replacing x in the original equation with negative 9 halves. So I'll have 4 times the number negative 9 halves, which is then squared, subtracting 81, and I'm checking, does that equal 0? So from here, I'll have 4 times, and negative 9 halves when squared will be positive 81 over 4, since negative 9 halves times negative 9 halves is a positive 81 over 4. So I have 4 times 81 over 4 minus 81. I'm checking, does that equal 0? And 4 times 81 over 4 will give me 81, so I'm checking 81 minus 81, and indeed that equals 0. So at this point, I've checked both of those proposed solutions, so I can state that the solution set is the set containing 9 halves and negative 9 halves. And I write that set by writing a curly bracket with 9 halves and negative 9 halves in it, separated by a comma.